This video, we're going to look at composition of transformation, so seeing multiple transformations together performed on the same figure or same point. We'll be working on pages 19 to 24 in our Algebra 1 summer math packet. It's only so many pages because the graphs take up so much space. Okay. So looking at our composition of transformation, we're doing a combination of multiple different transformations, and we're going to keep the order the problem tells us to do. So we have point A has coordinates A, -3, 4. What are the coordinates of A prime if the point is dilated by a scale factor of 2 and reflected across the line y equals -x? Because the dilation is mentioned first, that's what we're going to do first. So we want to remember a dilation of 2. That means we are just going to multiply each of our coordinates by 2. So we'll say 2x, 2y. Okay, so if A is -3, 4, after a dilation of 2, it's going to be -6, +8. Okay, now we'll do our reflection over the line y equals x. Y equals -x, excuse me. We want to remember that rule is xy goes to -y, -x. And that's something I would look up if I didn't remember it. So using that rule, -6, 8 is going to go to -8, +6, and that would be our final answer. And we could label that A prime as our final image. Okay? If we were asked for the in-between point as a part of our answer, we'd label that A prime, and then the last one A double prime. Okay. Point A has coordinates of A, -3, 4. What are the coordinates of A prime if a point is reflected across the y-axis and then dilated by a scale factor of 1/2? So the reflection is first, reflection across the y-axis. So that rule across the y-axis was that xy goes to -xy. So that would make our point 3, 4. And then a dilation of a scale factor of 1/2. That's xy is going to go to 1/2 x, 1/2 y, which would make that 3/2, 2, or 1.5. 2. Either way you format that is fine. If you want to leave it as a fraction or leave it as a decimal, doesn't matter. Okay. Triangle P undergoes a sequence of transformations resulting in triangle Q. Which sequence of transformations could be used to show that triangle Q is similar but not congruent to triangle P? So similar but not congruent tells me it's not an isometry or a rigid motion. So that means that the size changed. It had to have a dilation. And the only option with a dilation is D, a translation followed by a dilation. So that's where that idea of isometries and rigid motions comes into play, knowing that a dilation is not an isometry. So here we're given trapezoid RSTU and trapezoid NMLK on the coordinate plane. We're told they're congruent. Can clearly see that. Which sequence of transformations will map trapezoid RSTU onto trapezoid NMLK? So that implies that RSTU is the pre-image and NMLK is the image. So if I look at that on the graph, something I can see pretty clearly is that there was a reflection over the x-axis. Right? It clearly flipped over the x-axis. So I can already eliminate A and C, which says a reflection over the x-axis. So if I look at that reflection over the x-axis and I focus on point T, I can see if I reflected point T over the x-axis, it would land there. So then it also had to have a translation of one space to the left, which would give us answer choice B. Okay. You'll notice in the classwork, some of the questions are open-ended, where you're describing the transformations that could have occurred. Sometimes there's more than one correct answer. Okay, so keep that in mind.